The final part of our chapter on the line involves looking at where two lines intersect. Now, not in particular to the point of intersection, because you already know from a previous class that that point of intersection between two lines is found by solving a pair of simultaneous equations. But what we're more interested in now is when two lines cross, what's formed at that point of intersection. And the answer is 4 angles. Okay, now I want you to think about the 4 angles. If you take two lines that cross, okay, and just for a moment look at the 4 angles that are made, you'll notice that 2 of the angles are obtuse and 2 of the angles are acute. Okay, now what do I mean by that? When we talk about an acute angle is an angle that is less than 90 degrees. Okay, and an obtuse angle is an angle that is greater than 90 degrees. So therefore, when two lines cross, don't forget that the total number of degrees on either side of a line is 180. So when another line crosses them, that 180 degrees is broken into 2 angles. Now, if it's a perfect perpendicular relationship, you do 90-90. But if it's not a perpendicular relationship, just say that's one line. I have another line coming this way. One of the angles is going to be acute, and the other one's going to be obtuse. But the thing about it is that on both sides of a straight line, they will both add up to 180 degrees. And that's what that picture there demonstrates. If I take those two lines, they intersect here, obviously at that point. On one side of that point, you have 78.11 as my acute angle. So that's my acute angle here. And then on the other side, you've got an angle of 101.89, which is my obtuse angle. I-O-P-U-S-E, my obtuse angle, okay? But if you add 78.11 and 101.89, you're going to get 180. So that's one thing to remember, all right? Now, out of both of those angles, and we mentioned this when we were doing trigonometry before, but in trigonometry, the biggest angle we ever have to deal with is 90 degrees. Everything that we can do in trigonometry, we can do between 0 and 90. Because after all, if you think of a full circle is nothing more than 4 90s. Okay? If you take a circle like that and you put 0, 0 slap bang in the middle of that, you've got 90 degrees here, 90 degrees there, 90 degrees here, and 90 degrees there. So therefore, all of trigonometry can be carried out on 90 degrees. And then obviously the position of that particular area of the circle, the quadrant of the circle, we take that into consideration. That's later when we're doing trig. Okay? But for the moment, all I want you to remember is the acute angle is the one that's going to take our attention. Okay, the one that is formed by the intersection of two lines that is less than 90 degrees. Okay, so if, as says here, if the size of the acute angle alpha can be calculated, then we need a formula. So if we're able to calculate this angle and say we know what the slopes of the two lines are, then there's a formula needed. And again, and I keep reaching out for this all the time, again, you go to page 19 of your tables and you'll see just down here, that is the formula we're going to refer to, okay? And this formula here, which is the final formula on your course, is the formula for the angle between two lines of slopes M1 and M2. That's what it says in your tables, okay? So what am I going to do here? If I know, say for example, this is M1, the slope of that line is M1, and the slope of this line is M2, then if I use those two slopes together, I can work out the size of the acute angle between them. And obviously, once I get the acute angle, I can get the obtuse angle by taking the acute one away from 180. Okay, so that's the way it works. Now, what's the formula? The formula, it's in your table, so you don't need to learn off. You just need to remember it's on page 19, but here it is. The tan of the angle alpha, which, by the way, is the acute angle. Please remember that. It's the acute angle. So the tan of the acute angle alpha is equal to plus or minus the difference between the two slopes over 1 plus their product. Another way to say that, plus or minus M1 minus M2 over 1 plus M1 times M2. Okay, and if you're to get the two slopes and put the two slopes in here, what will come out will be the tan of the angle. Now, if the tan of the angle is equal to a certain number, and we wish to eliminate the tan to get alpha, the angle on its own, which is acute, then we will just inverse the tan on our calculators. The tan will disappear and the angle will emerge, the acute angle. Okay, so just keep that in mind. So what's the formula? The tan of the acute angle, alpha, is equal to plus or minus M1 minus M2 over 1 plus their product. Okay, so let's go straight into a number of examples, and I'm just going to look at that particular formula in this class, set you a couple of questions to do, and then once we finish this chapter, we're going to go into some exam questions. I'll bring you through them, then I'm going to set you an exam question to do, which you'll send back to me, and then we'll move on into the coordinate geometry of the circle. Now, I did tell you already, coordinate geometry of the circle is very, very similar to coordinate geometry of the line, so whatever we have used here, whatever we've learned here, we're going to carry forward into the next chapter. So, example, find the measure of the angles between the two lines, 2x plus y minus 6 equals 0, and 3x minus 2y plus 2 is equal to 0. Now, angles between lines. The angles between the lines are governed by a formula, and the formula is the tan of the acute angle alpha is equal to m1 minus m2 over 1 plus m1 m2. Okay, you can put brackets, remember, if you want, so plus or minus in there as well. So put brackets around those if you wish, because it's m1 multiplied by m2. So all I have to do in this question is get the two lines, pull out the slope of both of them, and stick it into the formula. And what that will do is it'll tell me what the tan of the acute angle is equal to. Then I eliminate the tan by getting the inverse tan on both sides, and the angle appears. Okay. Now, all the way back to the very beginning of this chapter, how do I get the slope of a line whose equation is given? The quickest way to do that, the slope of P is equal to minus A over B. So minus the first one, which is minus 2, over the second one, which is 1. So therefore the slope is minus 2. What's the slope of Q? Well, the slope of Q is minus A over B, which is 3 over 2. So now that I know the slope of P and Q, I simply put them into the formula. That's all I do. And I'm told the tan of the acute angle alpha is plus or minus m1 minus m2 over 1 plus m1 m2. So let's put them in and see what happens. That becomes plus or minus m1 minus m2. Now, it doesn't matter what way you put them in, okay? Because don't forget, the plus and the minus is in front of this fraction. So it doesn't matter which one you call m1 and m2. So don't get too worried about that. So I'm going to put down here minus 2 minus 3 over 2 over 1 plus minus 2 times 3 over 2. All right, now that's calculator work from here on in. So again, what did I do? This is m1, so m1 becomes minus 2 minus 3 over 2 divided by 1 plus minus 2 times 3 over 2. So let's just very quickly do that. Get out your calculator. We have minus 2 minus 3 over 2, which is the same, by the way, say minus 2 minus 1.5, which is minus 3.5 if you want to put it that way. But let's just do it on the calculator quickly. Okay, so that becomes minus 3.5. And then down below, what do I have? Well, the minus 2 will cancel with the plus 2. See that? Leaving you with minus 1. So it'll be 1 plus minus 3, which will become 1 minus 3, which is minus 2. So that's going to give me an answer of 3.5 divided by 2, which comes out as 1.75. Okay, now be careful. 1.75, that's the tan of the inverse angle. Tan of alpha equals plus or minus 1.75. Okay, now if I want to get alpha on its own, I have to get rid of tan. And the quickest way to do that is to get the inverse tan on the other side, 1.75. And that's on your calculator. On our calculators, you press shift with tan. So shift tan, think of it that way. Shift tan, what does it do? It shifts tan out of the way and it reveals alpha, reveals the acute angle. So shift tan of 1.75, and that comes out as 60.26 degrees. And that is the acute angle. Now, go back to the question. Find the measure of the angles. What's the other one? Well, it's the obtuse angle. Okay, so to get the obtuse angle, all I've got to do is take 180 and subtract the answer I've just got, which again gives me 119.74 degrees. And that's it. That's my obtuse angle. So again, if we want to get the acute angle between any two lines, the only two things we need to know are their slopes. End of story. We need to know nothing else. And once you know the slopes of those two lines, you plug them into the formula. What will come out will be the tan of the acute angle. You then shift tan out of the way on your calculator, and that will reveal the size of the acute angle. Subtract the acute angle from 180 degrees, and it'll give you the obtuse one. Okay, let's move on. Second example. Okay, we get that done. Good. So let me just take that writing off, because I've gone through it with you. We'll go through it here. So the slopes of the P is -2, Q is 3/2. Therefore, put it in, it's 7/4, which we said already, and we get 60.26, which is the acute angle, giving me 119.75 as the obtuse angle. Now, see that word in red? Complementary. If you can think back to your junior cert, what were complementary angles? Now, you had all kinds of angles in junior cert. Yeah, you had corresponding angles, you had vertically opposite angles, you had corresponding angles, or sorry, I said it already, didn't I? Corresponding, then you had vertically opposite, you had alternate, and now you've got complementary. What the hell are complementary angles? Complementary angles are angles that add to 180. So if you have angle A plus angle B giving you 180 degrees, then they are complementary angles. So any two angles that add to 180 degrees are complementary. Okay, keep that in mind. Okay, second example. Find the equations of the lines through the point 43 that makes an angle of 45 degrees with the line 6x plus y minus 5 is equal to 0. So find the equations of the lines. Again, listen to the plural statement. Find the equations of the lines through the point 43 that make an angle of 45 degrees with the line 6x plus y minus 5 is equal to 0. Now, if the two lines make an angle of 45 degrees, then immediately we're into this formula. The tan of the angle is plus or minus m1 minus m2 over 1 plus m1 m2. So in other words, I have to have the slopes of both lines. Okay. Now, what do I know in this situation? Well, I know the angle alpha is 45. I know that. I also know that the slope of the first line here, the slope of this line, is equal to minus a over b, which is minus 6. But I don't know the slopes of the other lines. So what I'm going to do is I'm going to call the second slope x. Okay, which now means that I have an equation to be solved in x. And because there's only one thing I don't know, I can solve this. So let me just go through that again with you. Okay, find the equations of the lines through the point 43 that makes an angle of 45 degrees with the line 6x plus y minus 5 equals 0. As long as you hear the angle between two lines, you immediately go to that formula. Okay, and then ask yourself, if I'm going to use that formula, what do they give me to put into the formula? And the answer is, when I read it again, they give me the angle of 45 degrees, which is acute. So that's going to be alpha. So you've got an alpha of 45 degrees. You've got a slope of this line here, which you're going to call m1, which is minus 6. And the second slope, or slopes, that we're looking for is going to be x. So all you've got to do is take that information and put it into this formula. And here's what it becomes. The tan of 45 degrees is equal to plus or minus minus 6 minus x over 1 minus 6x. See that? Okay, now notice equations of lines. You're going to have two answers here, so you've got to be very careful. So the tan of 45 equals plus or minus m1 minus m2 minus 6 minus x, that goes in the top line, over 1 plus the product of these two. So it's 1 plus minus 6 times x, which becomes 1 minus 6x. So now what do I do? Well, I'm going to take the tan of 45. I can get that on my calculator. The calculator will give me that. The tan of 45 degrees is equal to 1. Lovely. So the tan of 45 degrees is 1. And 1 is equal to plus or minus minus 6 minus x over 1 minus 6x. Okay. Now, there are two equations going to come from this. 1 is equal to the positive form of this. That means you just leave it alone. Or 1 is equal to the negative form of this, which is 6 plus x all over 1 minus 6x. Do you see that? So therefore, the positive form of that fraction stays as it is. A plus sign does no damage to anything. But minus the form of this one changes the signs of the top line. So you've got tan 45 equals minus 6 minus x over 1 minus 6x. Or you have tan 45 equals 6 plus x over 1 minus 6x. And all I've got to do now is use algebra. Get rid of the fraction. 1 minus 6x equals minus 6 minus x. Okay, and that becomes what? Let's work this out. We're going to bring that over here. That becomes 7 is going to be equal to minus 6. That's plus 6 minus x is equal to 5x. So therefore x is going to be equal to 7 over 5. Okay, second one. Clear the fraction again. 1 minus 6x equals 6 plus x. So in this case here, we're going to end up with 7x is equal to 1 minus 6, which is minus 5. So therefore x will be minus 5 over 7. Now, what are they? They're the slopes of the other two lines whose equations I want to find. So now, at least I know what their slopes are. So their slopes are 7 over 5 and minus 5 over 7. So how do I go back then to the question and get the equations of the lines? Well, that brings us back to the start of the chapter. To get the equation of any line, I need point, I need slope, and I need formula. Okay, the point is 4, 3. The slope is going to be 7 over 5 and then minus 5 over 7. And the formula is y2 minus y1 over x2 minus x1. Now I'm going to clear this, okay, because I now have the two slopes. Let me just write them down. So the point is 4, 3. The first slope, x1 is equal to 7 over 5. x2 is equal to minus 5 over 7. Okay, so I'm just going to clear this and I'm going to get the screen back so I can write it again. Okay, so now I want to get the equations of the lines now that I've discovered that the slopes I'm looking for are 7 over 5 and minus 5 over 7. So equation 1. What do I need? Point, slope, formula. What's the point? 4, 3. Yeah, that's given to me. What's the slope? Well, it's the first of the slopes we found. 7 over 5. What's the formula? Y minus y1 equals m times x minus x1. Okay, let's split this in half. So let's work this out. x1, y1. Y minus 3 equals 7 over 5 times x minus 4. Multiply everything across by 5 to clear the fraction. 5y minus 15 equals 7x minus 7 fours, 28. 7x minus 5y minus 28 plus 15 is minus 13, and that's equal to 0. So there's the first line. Now what's the second line? Well, the second line is the same point, 4, 3, but this time it's the second of the slopes I found a moment ago, minus 5 over 7, with the same formula, y minus y1 equals m times x minus x1. Okay, again put 4, 3 in as x1 and y1, and put your minus 5, 7 in as your slope, and then work out algebraically what the line is going to be. So y minus 3 is equal to minus 5 over 7 times x minus 4. Now you're going to multiply across both sides by 7 this time to clear the fraction. 7y minus 21 equals minus 5x plus 20. So I've just taken the brackets away and allowed the minus 5 in there. Minus 5 times x is minus 5x, and minus 5 times minus 4 is plus 20. So that will give me 5x plus 7y minus 21 minus 20 is minus 41 is equal to 0. And that happens to be the second line. So the whole problem here hinged on not knowing what the slopes were of the lines whose equations I wanted to find. So what I did algebraically was I allowed the second slope, the m2, to be called x. Okay, I shoved it into the formula that links up slopes with angles, and that told me that there were two possible values for x, 7 over 5 and minus 5 over 7. So they were obviously then the slopes of the lines that I'm looking for. So I used those slopes together with the 0.43 and the formula y minus y1 equals m times x minus x1 to build the equations. Okay, next question. A triangle has vertices 1 minus 1, 5, 1, and minus 2.5 minus 5. Calculate the value of the smallest angle in this triangle. Now, let's just take a look at that. What does that mean? Let me just take a look at the triangle. It doesn't have to be to scale. It doesn't even have to be in the right order, orientation, nothing. 5, 1, okay, minus 2.5 minus 5, whoops, minus 2.5 minus 5 for the full point. And then this point here, 1 minus 1. Okay, now find the value of the smallest angle. Okay, there's a trick behind this. And here's the trick. The trick is that the smallest angle is always opposite the smallest side. Okay? The smallest angle in any triangle is always opposite the smallest side. So you could, if you wanted to, work out the slopes of all three sides, take any two, put it into the formula, see what that is, then take the next two into the, and then too much work. Okay, let's take shortcuts. If you're serious about honours maths, shortcuts are all important. So here's what we're going to do. The first thing I'm going to do is I'm going to work out the lengths of each of the sides using the distance formula. And the distance formula then will show me which of the sides is the smallest, and therefore will reveal which of the angles is the smallest, and then I can use the slopes of the sides that make that angle in order to get the angle, the acute angle that those two lines make when they hit one another. Okay, so that's exactly what I'm going to do. So distance formula. Distance formula is d equals x2 minus x1 to be squared plus y2 minus y1 to be squared. Okay, so let's do it with this side here. Let's see what the length of that side is. So I'm going to plug them in and see what the distance is. x2 minus x1, 5 minus 1, 4 squared, 16, plus y2 minus y1 becomes 1 minus minus 1, which is 2, which is 4. So that becomes root 20. So that's root 20 in size. Okay, let's take the next one. Let's take this one here. X2 minus minus 2.5, that's 7.5 squared. So 7.5 squared is 56.25. Okay, so that's x2 minus x1 plus y2 minus y1, 1 minus minus 5, which is 6, which is 36. So therefore, we want the 56.25 plus 36, and that comes out as the square root of 92.25. Now you'll notice, I don't care what the square root of 92.25 is. I don't have it on top of my head. Leave it. Don't have to worry about it. And the last one then is the length between these two. So this is the square root of 92.25. And the last one then is between these two. x2 minus x1 becomes 1 minus minus 2.5, which is 3.5 to be squared, and 3.5 squared is 12.25 plus y2 minus y1, minus 1 plus 5, which is 4, and that's 16. So that's 12.5 plus 16, which comes out as 28.25. Aha. So if that's the square root of 28.25, you can see straight away that's the smallest side. So that is going to be the smallest angle, and that's what I'm going to use in the formula. Tan of alpha equals plus or minus m1 minus m2 over 1 plus m1 m2. All right, that's what I'm going to use. So now what I have to do, because I don't need the lengths anymore, just let me take the length off so I can fit in the slope. Take them out there, don't need them anymore because they're too long. Okay, so now what I'm going to do is try and work out, actually let me take all the distance out. Let me take all that away because I don't need that anymore. It's all just superfluous nonsense now. It's done the job we wanted it to do. Okay. That one there, that one there, there, and there. Okay, so let's take the slopes of these. Now, let's take the slope of this one. So we call this M1. Y2 minus Y1, which is minus 5 minus 1. Y2 minus Y1 is minus 6 over X2 minus X1, minus 7.5. There's the first slope, okay? Second slope here, well, y2 minus y1, minus 5 minus minus 1 becomes minus 4 over minus 2.5 minus 1, which is minus 3.5. So there's your slopes. There they are. Okay, so the first slope is minus 6 over 7.5, which is the same as 6 over 7.5. Now let me just see, does the calculator allow me to break that down? Let me just check this now. Let me put in that. Best thing to do with fractions always is put them into the calculator and see if there's an easier way to write them down. So 6 over 7.5, what does that come out as? That comes out as 4 over 5. Lovely, that's easier to use. So 4 over 5 is the same fraction. And then we have 4 over 3.5. What does that come out as? 8 over 7. Okay, good. So they're the two slopes. Now, tan of alpha is equal, and alpha is the acute angle in here, is equal to plus or minus m1 minus m2 over 1 plus m1 m2. So what does that become? Let's call this one m1 and m2. So we got 4 over 5 minus 8 over 7, 1 plus 4 over 5 times 8 over 7. And guess what? The calculator will do it for you. Let's do the top line. We've got 4 over 5 minus 8 over 7. So the top line becomes minus 12 over 35. Now don't worry about that just yet. And what does the bottom line become? Well, it's 1 plus 4 over 5 multiplied by 8 over 7. And that becomes 67 over 35. Okay. Now, I hope you remember from junior cert, when you're dividing by a fraction, there's no such thing. So this becomes minus 12 over 35 multiplied by 35 over 67. They're going to cancel. Minus 12 over 67 is the tan of the angle that we're looking for. So now, the tan of alpha is equal to plus or minus 12 over 67. So let's just try that and see what happens. Let's get alpha is equal to the inverse tan, because we want to get rid of tan, so shift tan on your calculator, the inverse tan of 12 over 67. And let's see what that tells us. So shift tan 12 over 67 becomes 10.15. 10.15 degrees, and that's the smallest angle in that triangle. So again, what did I do? If you're asked to calculate the value of the smallest angle is always opposite the smallest side. See that? Always. That's the quickest way for me to do this thing. So I got the lengths of the three sides. I discovered very, very quickly that this line here was the shortest line, so therefore the angle opposite that is the smallest angle, which I called alpha. I then work out the slope of this one, work out the slope of this one. The slope of that line there became 4 over 5. There's the first one. The slope of this line here became 8 over 7. And I simply fill them in to the tan formula. I get tan of alpha equals 12 over 67. I then shift tan to get rid of it on your calculator with 12 over 67. And I got an answer of 10.15 as my acute angle. Okay. Last one. For rain to run off a roof with no risk of water damage, the roof must have a pitch that is at least 15 degrees. If the gradient, now gradient means slope, okay? If the gradient of the roof is 0.25, is there a risk of water damage? For rain to run off a roof with no risk of water damage, the roof must have a pitch of at least 15 degrees. Okay, 15 degrees where? 15 degrees here. Now look at the diagram. There's the pitch, okay? So just let me magnify that up here a little bit. There's the pitch. Now what's the pitch between 15 degrees and here? The pitch is between the roof and this beam. But you notice anything? The slope of the beam is nothing. The slope of the beam is 0 for the very simple reason that it's horizontal. So horizontal lines don't have a slope. But what about the gradient of the roof? Well, that's what we're going to try and find out. What is the gradient of the roof? I'm hoping that the gradient of the roof, or by the way, gradient, right up here, gradient equals slope, okay? So I'm hoping that the gradient is going to be 0.25. So what I'm going to do is I'm going to take tan of alpha equals plus or minus m1 minus m2 over 1 plus m1 m2. And I'm going to see what angle do I get when I put in the 15, sorry, but not what angle do I get, but when I put in 15 degrees here, what slope do I get? Okay, so I'm hoping that the pitch must have a pitch at least 15 degrees. So for rain to run off a roof with no risk of water damage, the roof must have a pitch of at least 15 degrees. So look, I can do this in one of two ways. I can put in the 15 degrees as alpha and see what M1 comes out of and hope that it comes out as 0.25. Or I could put 0.25 in here with 0 for the second slope and hope that my angle comes out at greater than 15 degrees. Okay, and I think that's the way in which I'm going to do it. I'm going to take the slope and bring it in here. So there's M1. So M1, the first slope is 0.25 and the second slope is nothing. So tan of alpha is equal to plus or minus M1 minus M2. That's 0.25 over 1 plus M1, M2. So what happens when I multiply these two together? They both go to 0. So that's 1. So therefore the tan of alpha is equal to plus or minus 0.25. What do I want to do now? Shift tan. Get it out of the way. Alpha equals the inverse tan of 0.25. And here's what I'm hoping. I'm hoping that the answer is going to be 15 degrees or more. Okay, so let's do that. Shift tan 0.25. Answer, answer comes out as alpha is 14.04 degrees. In order for rain to run off, the pitch must be at least 15 degrees. It doesn't make the cut, okay? The pitch is too small. Is there a risk of water damage? Yes, there is. For the very simple reason that the angle required, the pitch of the roof, comes out to be actually 14.04 degrees, which is way less than the required 15 degrees or more to get the water to run off properly. Okay, so finally, I'm going to leave you with these questions here. Page 283, question 2, and then page 284, questions 5, 7, 8, 10, and 12. They are all on that formula. Use the formula. Figure out what they're giving you in the question that you can feed into the formula. See what part of the formula is to be left as the unknown. Mark it as X. Work with the formula. Try to find out what X is, and then do whatever the question asks you to do.